let's do some examples. Trying to keep the video short, so let's just do one. And we're going to be taking things to the nth power. When I say the nth power, to like squared or cubed or to the fourth or to the fifth, an nth power for any number. So let's do an example. This is like your homework. So here's our formula, de Moivre's theorem. We're going to use anytime you want to raise something to a power, as long as it's a positive integer, we're going to use this formula. So it says use de Moivre's theorem to find 4 times the quantity of cosine of 20 degrees plus I sine of 20 degrees, all raised to the third power. And when we're done, we're going to leave our answer in the standard form, a plus bi. All right, we're using everything and putting it together. Let's begin. Well, what we have over here, we're messing with, well, let's just think about it a little bit different. Let's say that z to the, and what power are we raising that to? Cubed? So we have a z cubed is equal to. Now let's look back up at our formula and see if one of these might be helpful. So a z cubed, so our n is 3. And it's sitting in this form here, isn't it? Right? There's the radius. There's your n. And then there's your cosine of theta plus I sine of theta. But it turns out that our theta is 20 degrees. So if we can just take it from here and just get to that point, and then we'll evaluate it, okay? So let's go. So we are going to say that our z cubed, I like writing that, just adding it on in. And I'm going to rewrite this whole dang thing. 4 times cosine of 20 degrees plus I sine of 20 degrees, all raised to the third power. Now let's use our formula. Let's go. Let's use de Moivre's. So we're going to take our radius, that 4 that's hanging out there, and we're just going to cube it. That does exactly what you'd think it would do. And by de Moivre's, we know that we're going to take our, whatever our angle is, it's always the same for both. If you have 2 different things, something's gone horribly wrong. Oops, I'm using a parenthesis. And it's whatever our power is. That 3, that's what we're going to multiply it by. So 3 times 20, 3 times 20. And since the question asks us to leave it in standard form, we're going to have to evaluate this. Now, we wouldn't be able to leave this anyway. You'd have to at least multiply the 3 times 20 to make sure that we are simplified. So let's clean it up. 4 cubed is equal to 64. 3 times 20, of course, is going to be 60. And there we be. Okay, so we have that it is equal to 64 times the quantity of cosine of 60 plus I sine of 60. So let's evaluate cosine of 60 degrees. And this is what we've been working for, right? So we know how to do this. It sucks if you have to look this thing up in your chart because you still don't know cosine of 60 or sine of 60. Hopefully this will be quick, right? So now we're going to say sine of 60 is equal to the square root of 3 over 2. I'm going to write my I right in the middle there, just so we can tell it's not underneath that root. And let's just simplify it out by multiplying. So half of 64 is equal to 32. Half of 64 is still equal to 32, but we got that root 3 hanging out up there, times I. Now, that's kind of funky. It's sometimes nice to put the I over here, as we've discussed. So depending upon how you want to write it, no big deal how you do it. Just make sure I can read it, huh? We'll leave it just like this. And that is our solution, left in our standard form of a plus bi. There's not much to de Moivre's. Once you learn it and you have the formula, come on, man. We have to bring the power and put it on the radius. And then we have to multiply. So we're multiplying and cubing. And then you just have to know your basic functions that we've been messing around with. Okay, so there's an example. I'll have another one for you in the next, and then we'll move on to our nth roots. Dun, dun, dun. So, see you there.